Astronomers are dazzled with a spectacular display of ice and dust jets as an interstellar visitor known as 3I/Atlas speeds toward the Sun. The alien visitor is firing off a massive jet toward the Sun, and it looks incredible. As this strange cosmic traveler races across the inner solar system, its behavior is turning into one of the most mesmerizing astronomical shows of the decade. Scientists across the globe, from professional observatories to independent sky survey teams, are closely watching the extraordinary plume erupting from its nucleus, a dazzling jet of vaporized ice and dusty material that continues to lengthen and intensify as the comet dives closer to our star. The sheer brightness and unusual geometry of this jet have left experts both amazed and deeply curious, because 3I/Atlas is not a typical comet, and its activity is not following the standard rules. It is an interstellar visitor, a mysterious wanderer from another star system, a cosmic refugee that has drifted through the darkness of space for untold millions of years before slipping unexpectedly into our solar neighborhood. Unlike ordinary comets that orbit the Sun in repetitive loops, 3I/Atlas is traveling on a hyperbolic trajectory, a shape that tells astronomers this object is not bound to the Sun's gravity. It came in fast, it will leave fast, and it will never return. Its speed and trajectory alone were enough to capture scientific attention, but now its spectacular release of gas and dust has transformed it into a once-in-a-lifetime observational opportunity. Telescopes across the world have been trained on its ghostly form, trying to decode the physics behind this strange, asymmetric jet that bends, twists, and flares in ways that defy the pattern seen in solar system comets. Some jets appear to burst from deep cracks in a comet's surface, activated by sunlight, but this colossal blast seems unusually potent, as though something trapped inside the nucleus has suddenly awakened. Astronomers believe the dramatic outflow may reveal secrets about the comet's composition, potentially offering a glimpse into material formed around another star entirely. Because 3I/Atlas never formed within our Sun's planetary disk, its building blocks are expected to be chemically distinct, carrying the signature of a foreign stellar nursery. Each molecule and dust grain released by the jet could be a messenger from a distant corner of the galaxy, shaped in an environment our own solar system never experienced. For scientists studying planet formation, this is an extraordinary gift, a free sample from another solar system, delivered right into our cosmic backyard. The jet itself is astonishing. Early images from the 2-meter twin telescope at Tide Observatory showed a luminous blade of material extending outward, shimmering with reflected sunlight, as though the comet were sprouting a bright, ghostly wing. The flare was so intense that astronomers initially questioned whether they were witnessing a normal outburst or something more exotic. As the days passed, multiple observatories confirmed the behavior. The jet was real, massive, and persistent. It seemed to pulse and shift, suggesting complex rotational dynamics deep within the comet. Unlike most comets that emit in smooth, consistent fans, 3I/Atlas released material in a way that resembled a pressure-driven geyser, as though internal pockets of volatile ices were rupturing after being dormant for eons in interstellar space. Part of the fascination comes from the unknown environment the comet once called home. Its origin star system is still a mystery. It may have been ejected from a young, turbulent planetary system during an era of violent gravitational interactions, or it may have drifted away from a stable home after passing near a massive body that flung it into galactic space. For millions of years, perhaps billions, 3I/Atlas wandered through the near-empty void between stars, exposed to cosmic rays, extreme cold, and microscopic bombardments of interstellar dust. These harsh conditions likely sculpted its surface, froze its volatiles deeper into the core, and altered its chemistry in unique ways. Now, as it heats for the first time since leaving its native system, every plume and eruption offers clues about its long exile in the darkness. The glow from the jet is now bright enough to be captured in detailed imagery by advanced sky surveys, and each new observation adds to the unfolding mystery. Instruments tuned to different wavelengths, optical, infrared, ultraviolet, are revealing a complex interplay of ices, minerals, and organic compounds streaming from a nucleus. Some components appear to be unusually pristine, suggesting that the comet has preserved materials that date back to the early life of its original star. If so, 3I/Atlas is a time capsule from another world, carrying information older than the sun itself. Such relics hold immense scientific value, revealing how matter behaves in other star-forming regions and how the broader galaxy recycles material through cycles of creation and dispersal. As the comet barrels toward the sun, its increasing temperature is intensifying the spectacle. The jet grows brighter, longer, and more chaotic as thermal stresses fracture the surface and expose fresh volatile pockets. Astronomers expect the outburst to continue, possibly becoming even more dramatic, as 3I/Atlas reaches perihelion, the point of closest approach to the sun. Some experts predict multiple explosive flares, producing temporary surges in brightness. Others speculate that the comet structure could be fragile enough to break apart under the pressure, scattering fragments that would reveal even more about its interior layers. Whatever happens, the days surrounding its solar encounter are expected to deliver a wealth of new insights and some breathtaking imagery. Public excitement around 3I/Atlas has also skyrocketed. The strange object has become a trending topic on social media, where users share animated telescope clips, time-lapse sequences, and digital reconstructions of its hyperbolic path. Many compare it to Oumuamua, the famous interstellar visitor discovered in 2017, though 3I/Atlas is behaving far more dramatically. Unlike the cigar-shaped Oumuamua, which showed no visible coma or tail, this new visitor is bursting with raw, energetic activity. Other people liken it to Comet 2I/Borisov, the second known interstellar object, which displayed a classic cometary tail. But even Borisov did not exhibit a jet as striking as the one currently emanating from 3I/Atlas. Each comparison emphasizes the uniqueness of this new arrival and the sense that we are witnessing something entirely new in the recorded history of astronomy. Even theoretical physicists have joined the discussion. Dr. Michio Kaku and others have highlighted its unusual hyperbolic trajectory and exceptional velocity. Because it is moving faster relative to the solar system than typical comets, the physics of its interaction with the sun's solar wind, radiation pressure, and magnetic environment will be subtly different, giving researchers a rare opportunity to test models of interstellar object behavior. Observing the jet's response to solar forces may refine our understanding of how material escapes from small bodies under extreme conditions. If the jet twists, narrows, broadens, or suddenly collapses near perihelion, each shift will help physicists map the internal structure and rotational state of the comet. Despite all the excitement, scientists also acknowledge that interstellar visitors like this are bittersweet. They come quickly, leave quickly, and rarely offer second chances. After 3I/Atlas swings around the sun, its hyperbolic orbit will fling it back into the dark, bound for the endless gulfs between stars. Once it recedes into the black, it may never again be detectable with human instruments. That makes every moment of observation precious. Teams are coordinating worldwide, ensuring that no data is wasted. From amateur astronomers capturing telescopic snapshots to powerful observatories tracking its spectrum, the global scientific community is racing to collect as much information as possible before the comet vanishes forever. For now, though, the star of the show remains the jet, an unearthly beam of ice, dust, and gas that glows with the intensity of a distant beacon. It is a reminder that the universe is full of wanderers, mysteries, and ancient travelers that sometimes grace our skies with fleeting brilliance. As 3I/Atlas continues its approach, astronomers watch breathlessly, knowing they're witnessing something extraordinary. A raw, spectacular display from a visitor that was never meant to be here, a relic of another world performing a final cosmic dance before disappearing back into the void.